In lesson 3.4b, we're going to kind of put together everything that we've been talking about and just go in a little bit more depth with finding these zeros. So one of the things that we know about factors of a polynomial is if you have a polynomial of degree n with real coefficients, it can be written as a product of linear and quadratic factors with real coefficients. Okay, so we can generally factor these. And we'll see that here in a minute. But first, we're going to find all the real zeros. We were doing these yesterday as well, so we're just going to keep working on these. So one of the things that we talked about is that with complex zeros, they always come in pairs. So if we know that 1 plus 3i is a zero of f, that means its conjugate 1 minus 3i is also a zero. So we know 2 zeros, it's degree 4, so we think there's going to be 4 zeros of this. There are 4 zeros. So remember, we can write the factors of this. So just like if one of the zeros is 5, the factor is x minus 5. If one of our zeros is 1 plus 3i, one of our factors is x minus 1 plus 3i. Oh dear, that was terrible handwriting. Let's try that again. X minus 1 plus 3i. Now notice I've put it in parentheses because we actually have to distribute that negative. So we get x minus 1 minus 3i. That's one of our factors. The factor with this is going to be x minus, and again, put in parentheses, 1 minus 3i. So again, just as if the zero had been 5, our factor would be x minus 5. Our zero is this more complex thing. Our factor is still x minus that more complex thing. We're going to distribute that negative, so we get x minus 1 plus 3i. Okay, so now we know 2 of our factors, 2 of the factors of our 4. What we can do is multiply these 2 factors together and then use long division to get our function down to something a little simpler. So I want to multiply these 2 things. I could FOIL the whole thing out. I think I'm actually going to use the box method for this, just to be a little easier. So I'm going to do x minus 1 minus 3i here. I'm going to do x minus 1 positive 3i here. And I'm just going to multiply this box method. So I get x squared negative x, negative 3ix. Then I get negative x, positive 1, positive 3i. Get 3ix, negative 3i, and negative 9i squared. And I'm going to have some terms canceling. Those are going to cancel, and these are going to cancel. So that leaves me with x squared minus 2x. And then remember, I have 1, negative 9i squared. Remember, that's negative 9 times negative 1. So that's actually a positive 9. So plus 10. So when I multiplied these 2 factors, this is what I got. X squared minus 2x plus 10. So we're going to take that and divide it into the original, x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. And we're just going to do our long division here. So I'm going to need an x squared on top. That gives me x to the 4th minus 2x cubed plus 10x squared. Draw the line and change the signs. That's a negative there. So we get negative x cubed minus 4x squared plus 2x. I'm going to need a negative x on top. That'll give me negative x cubed plus 2x squared minus 10x. Draw the line and change the signs. Gives me negative 6x squared. Let's see, it's a positive now. Plus 12x. Drop the negative 60. And lastly, it looks like a negative 6. So get negative 6x squared plus 12x minus 60. Draw the line, change the signs. Everything cancels. Okay, good. So now that I've reduced that, I'm going to take this thing and I'm going to factor it further. That's going to give me x minus 3, x plus 2. Now I have completely factored it. Remember, I have 1, 2, 3, 4 factors. And so the zeros of my function, if we take this and set it equal to 0, we get 3. If we take this one and set it equal to 0, that was supposed to be a colon. There, can you see that? So we get 2, and we already knew that 1 plus 3i is a 0 and 1 minus 3i. So those are the 4 zeros of this function. Since I've made a huge mess of this page, we will do part B in the next video.